All right, we're going to use the last two videos, knowledge from the last two videos to help us get a little bit of practice when it comes to all of these factoring problems. And what we're looking at today are some different scenarios where you're going to have to use all your factoring skills and factoring knowledge to get the correct answer. So the first thing I'm going to recognize here that this is written out of order. It's just written backwards. And the reason that it is because the a squared term, the coefficient of the a squared term is negative. So the first thing I'm going to do is I'm going to factor out that -1. And that's going to give me negative times 3a squared minus 21a plus 10. Now it's more familiar to me, and I'm going to draw that little x there. And I'm going to multiply a times c, which is 30, and get the middle term b, which is -21. So I'm going to write myself a list out here of all of my factor pairs of 30. So that's going to be 31 and 30, 2 and 15. Be deliberate. See how I'm counting up here. 3 and 10. 4 doesn't work, but 5 does, and that's 5 and 6, and then 6 and 5. Oops, I'm repeating, so that means my list is done. I'm going to look through my list carefully. I'm going to find the two factor pairs that give me 21 somehow, and that's going to be none of them. So I'm going to use that old term for a trinomial, which is not factorable, which is called a prime. And it doesn't mean it doesn't have a solution. It just means that we can't factor it in order to find our solution. So just remember moving forward from here that factoring does have its limitations. You can't solve every quadratic equation by factoring. At first glance here, I don't have any GCFs, so I'm just going to go ahead and do some four-term grouping here and see what I can come up with. And that's going to give me 4x squared, and that's going to be x minus 4. I see the plus 5 here is going to give me x minus 4. So this time, four-term grouping did give me a little bit of a simplified version here, so that's why I'm going to go ahead and use it. And x minus 4. So there is my final answer. Now the reason I would stop for just a second is I would look at this and I'd think, okay, is there a way to factor this any further so that I can make it more simple? And the only way that I could would be if this was a perfect square. And so you'll notice that the first one is 4x squared is 2x, quantity squared, but 5 is not. If we change this real fast to 4x squared plus 25, we'd be getting closer. And if we changed it even further to say 4x squared minus 25, then we could employ the difference of squares here. And so you just want to remember that if you have any term or any degree of your exponent other than a degree of 1, there's the possibility that you could simplify that binomial a little bit further. In this case you can't, but you just got to keep an eye out for that in the future so that if that's possible, you can actually do that. Again, there's no GCF here, but I do see the four terms, so I'm going to give four-term grouping a try again, and it's going to be x squared times x minus 6, and then I'm going to factor out that -1, because see how this one is a minus and that one's a plus. I got to factor it out so they're the same, and that's going to give me x minus 6, and then I get x squared minus 1 times x minus 6. And here's what I was talking about, because I have a degree of an exponent which is greater than 1, and I've got a perfect square. I've got a second perfect square. Remember, number 1 is a perfect anything, so that is 1 squared is 1, and it is a difference, so that is the difference of squares. So I'm going to rewrite this as x minus 1 times x plus 1. And of course you can't. Got ahead of myself there. I was about to say you can't forget about that x minus 6, and I just went ahead and wrote that. All right, so the final simplified form of this is x minus 1, x plus 1, and x minus 6, because this is the difference of squares. Keep an eye out for that in the future. This will be the first time that you guys get to see double variables like this, at least in the notes. You may have had some practice problems that kind of snuck these in here. But don't get worried about them. It's no different. It's all the same. So I'm going to draw my little x out to the side, and I'm going to put a times c, which is -3, and then add 2 down at the bottom. And that's going to be 3 minus 1. That's going to give me what I need. And just remember, whatever variable or variables are on your middle term, that's what goes on your middle term when you split it. So it's going to be a squared plus 3ab minus 1ab minus 3b squared. Use my 4-term grouping here, and I get a times a plus 3b minus b times a plus 3b. And then I get a minus b times a plus 3b. All right, down here to questions 5 and question 6. So you look at this, and it really looks kind of confusing, and you're like, okay, well, I'm going to just distribute these back together, and I'm going to multiply this out and give me what I need. And that's going to be the long way, or whatever. Doesn't matter. So why don't I go ahead and do that for those of you who just want to see it done this way. And then I'll go ahead and show you the other way as well, so then maybe you can pick up on that. We'll go ahead and use the perfect square trinomial strategy here. So that's going to be a minus b. So that's a squared minus 2ab. So 2 times a, that's 2a. 2 times 2 is 4. So that's going to be minus 4a. And then I've got b squared, which is 2 squared, which is 4. I'm going to combine some like terms here. I'll underline my a's and circle my numbers. And that gives me a squared plus a minus 6. And then from there, I can go ahead and factor that. I'll use my little x here, and that's going to be negative 6 and positive 1. So that's going to be 3 and negative 2. So that's a plus 3 and a minus 2. See how I did that? That was mental factoring. I recognized that the coefficient of my a was 1, and so since that's the case, my factor pairs are the answer. So it's a plus 3, a minus 2. Okay, now let's backtrack. We'll go back again, and we'll look at this a little bit differently. We're going to look at it from the terms of GCF. You'll notice you have one term here and another term here. Well, what do they both have in common? The number a minus 2, right? So that means I can take out that GCF of a minus 2. So I'm going to go ahead and put a minus 2 out in front, and then what's left inside? Well, if I divide a minus 2 from 5a minus 2, the only thing left there is 5. If I divide a minus 2 from a minus 2 squared, then what's left there is a minus 2. And then I'm going to go ahead and rewrite that by combining like terms, and I get a minus 2 times a plus 3. So if you can see that, it makes it a whole lot simpler. But it really doesn't matter because you get to the same answer either way. So just think about it in terms of what you're more familiar with or what you recognize, and go ahead and go from there, because it's really not a big deal. It's just what you prefer looking at. Okay? And now this one's a little bit confusing, but this 49 should give you a little bit of a clue. The 49 is a perfect square, and it's being subtracted. And this squared term right here means that m plus 3 is also a perfect square. So I'm going to go ahead and rewrite this like we did in the notes the first day so that we can see it a little bit more clearly. And then I can go ahead and simplify this the way it's supposed to be simplified. Okay, so if a squared is m plus 3 squared, that means that a is m plus 3. And then, of course, 49 is 7, so that's going to be plus 7. And again, if a squared is m plus 3 squared, that means that a is m plus 3. And I repeated that because I just wanted to kind of ingrain that in your mind, because it's confusing why there's two terms here, but that's because a is m plus 3. And of course that's minus 7 there. Now I can combine like terms here and I get m plus 10, and I can combine like terms here and I get m minus 4. And so that one's a little bit tricky, but if you can see the difference of squares in it and then combine like terms, it's really not that difficult of a problem. So come prepared tomorrow with any questions that you might have covering any of the factoring over the last 3 days, because after today we're really going to want to have a solid method for doing this and some real solid strategies for solving these problems efficiently and quickly, because we're going to be moving on into different parts of this unit from here on out.